Hi, my name is DDavis. I'm an acoustics engineer. This is a conference paper that I gave at the Acoustical Society of New Zealand conference in Wellington in 2022. It's a description of a method that I've developed to use a risk management based method to control construction noise impacts, and also I've developed it a bit further to use a fuzzy logic type calculation tool to help assess and manage those construction noise impacts. So construction noise impact is an environmental risk, and the construction site needs to manage that risk. And they normally do that by asking acoustics experts to help them, and the acoustics consultants usually try to do that by doing things like noise modeling and noise monitoring and giving the construction site advice in how to manage the noise in terms of decibels. But the problem is that most of the construction site people don't necessarily understand decibels. My contention is that they don't need to understand decibels. They don't want to understand decibels. It is the acoustics consultant's job to interpret the decibels into the language that the client, the construction site, does understand, and that is risk. The risk management process is quite well established and quite well understood already. One of the first steps is to undertake a risk assessment. And one of the first parts of undertaking a risk assessment is to identify the hazards. So if you're going to identify the risk hazards associated with environmental noise from construction sites, you would start by thinking about the noise sources. And you would think about it in terms of how loud are those noise sources, how much noise are they emitting, and also you need to think about how annoying is the sound that is being emitted by those noise sources. And you would also need to think about the receptors, so how many receptors are going to experience this noise. And you also need to understand how close they are, because that's going to determine how loud the noise is at those receptors. You also need to think about the time associated with the noise impacts. So that means for things like the duration of the construction project. So how long is it going to last? Is it going to last for days or weeks or months or years? You also need to understand what time of day or evening or night, or even on the weekends or public holidays, when the noise is going to occur. And you need to think about the community. So what is the community's view of this project? How sensitive is this community to noise impact? For instance, what is the existing noise levels in this community? And what's the background noise levels? That's what determines how sensitive a community is to noise impact. And also, what is the community's opinion of the project? So are they for or against the project? And that has a direct influence on the amount of impact that an environmental noise has on a community. So our job as the acoustic advisors to this construction site is to help them manage their total environmental noise risk, which means we need to be able to identify which of these environmental noise risk input factors are resulting in the total site project environmental noise risks. And we need to be able to identify which of these we should focus our efforts and attention on to get the best bang for our buck to reduce the total environmental noise risk. That means we need a tool to help us do that. We need a tool to help us identify where we should focus our efforts and attention to achieve the best overall result in reducing the environmental noise risk. So you can collect those various environmental noise risk hazards and simplify them a little bit and combine them into these joint type risk assessment matrices. So for instance, the noise levels, if the noise levels being emitted from the site are low or moderate or high, and the noise character of those noise emissions are not very annoying or moderately annoying or highly annoying, then you can combine those into like an overall risk rating for the noise levels and the characteristics of that noise into an overall noise risk rating. And similarly, you can do that for the time dimension of this noise impact in terms of the times of day. Is it happening during normal hours like daytime or evening or other times, more sensitive times? Is it happening over a short period, a few days, weeks? Or is it happening for a long time, months or years? So you can combine those into an overall time risk rating. And similarly, you can do that for the receptors. Are there few receptors? Are there a sort of intermediate number? Are there many of them? Are they far away, or are they sort of not very far but not too close, or are they very close? So there you've got a receptors type risk rating. And the community opinion of the project, if they have a high opinion of the project or if they have a low opinion of the project, you can combine that with the sensitivity of the existing noise environment. Is it loud already? Is there lots of noise already? Or is it not very loud? Or is it a very quiet environment? You can combine that into an overall risk rating for the community opinion of the project. Now, of course, the thing about noise impact is that you don't have any impact if you don't have any noise. So the noise sources information is critically important. For instance, the time dimension, the information about the receptors and the information about the community opinion of the project, none of those things matter without the noise sources. So in terms of the noise risk associated with this project and these other three hazards, they need to be combined. So instead of 4 dimensions, 4 types of risk hazard for noise impact, we only have 3. We have the time dimension, but it has to be considered in terms of the noise. And the receptors dimension has to also be considered in terms of the noise. And the community dimension also has to be considered in terms of the noise. So the combination of those reduces this complexity down to only 3 risk hazard factors now. And what that means is that the overall project noise risk needs to be considered to be the combination of those 3 dimensions. So the receptors times the noise, the time dimension times the noise, and the community sentiment times the noise. And realistically, the overall project noise risk is going to be the higher of these 3 input factors. So if any one of these 3 is a high risk, then the overall project noise risk will be high. If all 3 of these are medium, or any one of these is medium and the other ones are lower, then the overall noise risk will be medium, and so on. So we need to combine those risk hazards. And if we combine them like this, where all of the different risk hazard dimensions can be multiplied by each other, then all of the inputs can be combined into a total overall project noise risk. So if all of the various input hazards have a low risk, then the overall project noise risk will be low. Similarly, if all of the various noise inputs are a medium risk, then the combined total noise risk will be medium. And if all of the various inputs are high risk, then the total overall project noise risk will be high. Now in practice, all of these project risk inputs can be different, and the total overall project noise risk will be equal to the highest of any of them. So depending on which of these 3 risk inputs has the highest overall risk, the project overall noise risk will be equal to the highest of any of those three. So now we have a tool whereby we can identify where we should focus our efforts to try and reduce the overall project noise risk. Now we know which of the inputs are causing the total overall project noise risk, and that will help us decide where we should get the best bang for our buck to try and reduce the total overall project noise risk. We can focus on which of the inputs is causing that. Now this is a very manual way of doing it. This is a very manual way of connecting the cause and effect relationships between the various input factors. It assumes that you have a very clear understanding of the exact amount of connection between the different factors and how they relate to the overall total risk. It doesn't really allow very much flexibility from site to site or from day to day. It doesn't really allow for an extra dimension of uncertainty. That's a major limitation. So now I wanted my risk assessment and risk management processes to try and take into account some of that uncertainty. So I found some software which is used for mapping out fuzzy logic. And that enables you to incorporate not only the strength of the connection between two variables, so the strength of the interaction between two things, the cause and effect relationship between two things, but you can also incorporate a level of uncertainty into that connection. So not only can you determine that one thing will have a strong influence on another thing, but you can also incorporate how confident you are in the strength of that connection having that effect. So a very strong effect can have a very strong confidence rating or a not so very strong confidence rating. And this is one of the models that I have built in this fuzzy logic cognitive mapping software to map out the relationships between different variables in an environmental noise risk assessment and management system. You can build a model either in graphical form like that or in a matrix form like this, where you can change the interactions between different variables numerically. So this is a numerical way of directly affecting and changing the strength of the interactions between the different variables. Or you can build a model like this in the graphical interface, where you can just directly influence the strength of the connections between different variables by just changing that connection, and you can change it to either being a positive connection or a negative connection, so that a positive change in one variable can lead to a positive change in the other connected variable, or a positive change in one variable can lead to a negative change in the connected variable. And in this graphical interface, you can also just directly change the amount of uncertainty in the connection between variables. So once you choose a connection between two variables, you can then directly change the confidence rating, which is the level of uncertainty in that connection between those variables. And this is an example project that I have built specifically to illustrate the power of this software. In this particular situation, we have a community which is very sensitive to the time of day that the construction noise impact stops. So in this case, we have the construction noise impact extending just slightly too long during the day, and the overall project risk is very high. But in this fictitious community, when we change the time of day when the construction noise stops to just under the maximum allowable time limit, then we find that we have a huge change in the overall project noise risk, because this community, which was very sensitive to the time when the noise stopped, was now very happy that the time when the noise stopped was just under the limit instead of just over the limit. So this software also lets you do what-if scenario type investigations, where you can change the variables manually and see the instant effect on the total overall outcomes of the project. So this is a way of playing with the input variables and seeing what effect it has on the total overall result. So this can show you very quickly if any of these variables has a large increase or decrease in the total overall project risk, or not much at all. So this is a way of directly interrogating the risk model and learning for yourself what gives you the best bang for buck in terms of improving or worsening the total overall project noise risk by changing any of the input variables.